In this video, we're going to learn how to declare and initialize variables in C#. After that, we'll learn about different data types that we can use to store variables, and then we'll go over a quick example of how we can put numbers in these text boxes and then perform math on them and output the result in this label. So we'll put a number here, you click the add button, and the sum of those two numbers will be output right there. So first, let's talk about the difference between declaring a variable and initializing it. So to declare a variable, all you do is you say, here's our data type, or our variable data type. So we want it to be a string, and we'll call the string, we can name this whatever we want. I'm going to call it myString. And that's it. That's how you declare a variable. You basically say that the variable exists, it has a very specific data type, and that's it. Now, string data type is just any combination of letters, symbols, numbers, whatever. Any combination of that stuff, and you can view it, you can input it, you cannot perform math on it. We'll talk more about that later on. But a string is a very generic data type, which is why I'm using it right now. Now, in order to initialize a variable, what initializing means is you're giving the variable an actual value. So we're going to assign a value to this string, and I'm going to do it incorrectly first, just so you see how it looks when it's incorrect. I'll say this is a string that I will output. And as you can see, there are a ton of errors here, like a ton of them. So why is this? Well, whenever you initialize a string, whatever it's equal to has to be inside quotation marks. It has to be. So let's do that. And everything is good. So this is what we have. Let's go ahead and look at what this looks like when we output it into our system or into our program. Let's say, so label result is the output label I showed you earlier. And let's run the program. It's probably going to be too big to fit in the entire label, but you get the idea. Yeah, it's too big to fit in here. I would need to adjust the size of the program, but basically the string gets output like so. It's just a regular string. Now, of course, strings are not the only data type we have. There's also a data type called char, and I'll say it's mychar. And a char is going to be, it's kind of similar to a string, except you can only have one letter, or one number, or one symbol. And instead of being surrounded by quotation marks like so, it's actually surrounded by an apostrophes. So two apostrophes, opening and closing apostrophe. So let's say the letter R is going to be output or assigned. So right now what we did is we declared the variable myCharacter, and we assigned the character R to it. Let's try to output this into our label now. Now, as you can see, there is an error message. You may be wondering why, and of course I'll tell you. Whenever you output something into a text field, or a label field, or anything that goes into a text property like this, it has to be in a string format, or string data type. And this, unfortunately, this is a character, so we have to change it to a string. So there are a couple of ways to do this. I'll show you the better way to do this. It uses something called the toString method. So after the variable you want to convert, put a period and type in toString, and then an open and closed parentheses. And that should work. So let's take a look. And it should output the letter R. And there we go, the letter R. And the reason why this works is because we declared it as a character, but then we converted it to a string. So that's character, and that's string. Now let's talk about another data type called a Boolean. Now Booleans are a little bit trickier to understand why you would use them. When we talk about if-else statements or loops, the Boolean variable type will become more useful, but for right now just understand a Boolean can take one of two values only, either true or false. And that's it. There are no other values that it can take. So let's see what happens when we try to convert it to a string for outputting. And there we go, it outputs true. Now normally you wouldn't be doing that. You wouldn't normally be outputting the actual Boolean value. You'd be using the Boolean value to perform some kind of logical operation. But that's basically a Boolean right there. And then we also have a few data types that are numeric data types. So we have things like int, we have float, we have double, and we have decimal. So all the values, all the variables I showed you earlier already, you cannot do any math operations on them. You can't use them for addition or subtraction or multiplication or division or anything like that. A variable must be converted into one of these numeric formats in order for math to be performed on it. An integer is the simplest type of numeric variable. It can only take the value of like a whole number, or basically an integer, a positive or negative number that has no decimal points. So it can be like -10 or -1,000, or it can be 0, or it could be 54 or 92, or any whole number that doesn't have any kind of decimal place, no fractions, nothing like that. Just a regular integer, positive or negative. A float and double and decimal, on the other hand, they are able to hold numbers that have decimals. So float can be really any number, positive or negative, that has a decimal like 3.14 or 7.982 or something like that. Same thing with double, same thing with decimal. The only difference between these three is the amount of decimal points that they can hold, or the number of decimal spaces that they can hold. So a decimal has by far the largest capacity for storing numbers, so you can have the biggest range of positive or negative numbers using a decimal data type. Now on the other hand, the float data type is on the other end of the spectrum. It holds the smallest potential values, or the fewer possible digits of these three data types right here. So if you're going to have a decimal type value, but you don't expect it to be very big or complicated or have many decimals, then you may consider using a float. And of course, a double is in between. So let's quickly initialize these. Let me just initialize the integer variable. I'm going to do it incorrectly just to show you that it is in fact incorrect when you try to do a decimal. So 3.8 should give me an error. See? Error. And let's get rid of that. Next, let's initialize the float. Let's mix it up and try maybe doing a negative number. So let's say negative 52.5. And this will give me an error again. And the reason why, this is kind of weird, but when you initialize a float variable, you need to put the letter F at the end of it, and that'll make it work properly. but just remember you need that f to identify that it's a float. A double, again, a double is just anything with decimal points, so let's say 1000.39612. And works just fine. You don't need to put any suffix on because actually a double is considered to be the, I'd say the standard decimal type or floating point type of variable. And then decimal, finally, let's do 3.14, and you have to put the letter M at the end of it to initialize a decimal. So F is required for float, you don't need anything for a double, and you need to have an M for a decimal. So what I'm going to do is I'm just going to use the decimal variable only, just because I prefer using decimals over doubles or floats or ints or whatever. And we're going to perform some math with our program over here. So I named my two text boxes text num1 and text num2. So the first thing you want to do is you want to take the values in the text boxes and insert them into decimal variables. So I'm going to declare two decimal variables, num1 and num2. You can just declare them like that, one after another. And if you want to give them initialized values, you could do like value 1 and value 2 or whatever, and this would work fine too. But for this example, we don't want to initialize them yet. We just want to say these are variables that we can assign values to later on. What we'll do next is we'll say num1 equals, and the way I'll do this at first is going to be intentionally to get an error. So let me show you the actual error. So we have txt.num1.text, and we have an error. Why is that? Well, remember earlier I said that when we output information to a label, that information needs to be in a string format? Well, in order to take information from a text box or from a label, from anything, in order to take information from an object, or in order to output information into an object, it has to be string, or it has to be a string data type, or basically whatever you have here is going to be a string data type. So this right here, the text property, this is a string, and we're attempting to store it into a decimal, which won't work. That's why we have our error message. So what we need to do is first we need to convert this right here, we need to convert that into a decimal. So let's do that. There's this really handy command called the convert command. And there we go. We have converted our string into a number, like so. And let's do the same thing for the other text field. I'll just copy, paste, change it to num2, and there we go. So now that we have our decimal numbers initialized, because these are basically initialization statements right here. That's what these are. Once we've initialized our decimal values, we can add them together. So let's create another variable. Up here we're going to declare it. And we're going to say this is where the sum total of num1 and num2 will get stored. So we have sum equals num1 plus num2. So now that we have our sum variable, we performed our addition. We can now output this result into our output label, which I think is called LBL results. Yeah, LBL result. And again, I'll do this incorrectly at first just to show you. So like I said earlier, in order to take information from our text box and put it into our decimal variable, we need to first convert it into a decimal, and then it properly stores. And likewise, when we're outputting information into the label, we need to first convert that back from a decimal into a string. So we're going to do this toString command. And there we go. So let's see if our math actually worked. All right. So let's put the number 11 and let's say 82. So this should give, actually no, let's do a decimal actually. Let's do 82.5 and 11.4. So if our math is correct, then we should end up with 93.9. And look at that, 93.9. And if we update the numbers, we can say maybe instead of 11, we'll do 33. It updates the value as well. So that's how to do a basic math operation. And of course, if you want to do subtraction, you can do a minus sign. If you want to do multiplication, then you need to use an asterisk, like so. And if you want to do division, you use a slash. You can also use something called a modulus operator. And what a modulus, it's a percent sign. What a modulus does is it divides the first number by the second number, and whatever the remainder would be after doing the division, that's the result you would get. So let's do another example just to show you how the modulus works. Let's do something simple. Let's do 7 and 3. So 7 divided by 3 would be, would be 2 with a remainder of 1. So the output should be the number 1. Let's see if it works. And there we go. The number 1 has been output. But essentially that's how you do some basic math using Visual Studio. Now there's one last math I want to show you. And this is using something called a math package. As part of your .NET framework you have with Visual Studio, you have access to a bunch of bundles of predefined methods or predefined things that you can use in your program. So there's a package that's called, like I said, the math package. And it has a number of different things that you can use. You can do a logarithm, min, max, pow, tangent, square root, etc. I'm just going to show you the pow. You can explore the rest on your own if you'd like, but I'm just going to use the pow one for right now. Pow basically means power or exponent. And what that does is, in this case, it takes whatever number 1 is, or the first number is, and it puts it to the exponent of the second number. So if num1 was 5 and num2 was 2, then it would be 5 to the second power, which is 25. So let's go ahead and replace the text right here with that. And again, it's important that you always proceed with the name of the package you're using. Now the reason why these have error messages is because methods like pow, they actually require you to use a double data type. Not decimal, but a double. So I'm going to go ahead and replace decimal with double everywhere. So replace 2 decimal with 2 double. And we'll see if it works now. It should work. So let's do 7 to the second power. That should be 49. And there we go, 49. Now something that you can also do is you can take the square root of a function, or the cube root of a function, or the fourth root of a function, or fifth root, or something like that. And you can actually, I recommend actually that you use the POW method to take roots. So let's say, for example, we want to do the whatever is in our text box, the first text box, right here. What if we want to take that text box and put it to the third root every time? Well, third root would just, the third power every time. So if we took it to the third power every time, we would just do to the number 3. And that's pretty much all you'd have to do, because going back here, let's just do, 2. I'll just put some random number down here. 2 to the third power is 8, and we got 8. However, if we want to take the root of that number of num1, then we have to do 1/3 instead. So instead of doing 3, you take the inverse or the reciprocal of it and do it as 1/3. And by the way, this will actually give us an error called a runtime error. Let me show you what the error looks like really quickly. So we'll take the third root of, I know 125 is going to be 5, so it should be 5. And click add, and it gives you 1. So the way to fix that error, because it's not super obvious, but the way to fix that is when you write your code, you need to actually put 1.0 and 3.0, just to help to, I guess, better declare or better specify that these are in fact doubles and not integers. So let's try that again, and this time it'll work. So 125, and I'll just type in whatever number here, click the add, and we got the correct result, which is 5. Now you may be wondering, why am I adding a bunch of numbers to this text box? I didn't really explain that yet, did I? Well, I promise I'll have an explanation right now. So the reason why I add these numbers to the text box is because if I don't, then I'm going to get a runtime error. And let me illustrate that really quickly. I'm going to delete that and click add, and I get a runtime error that says, uh-oh, problem happened. So why does this happen? Why did I get a runtime error when I didn't type stuff into that second text box? Well, this line of code assigns whatever is in the first text box, converts it to a double, and puts it into the num1 variable. And the same thing here happens with the second text box. Now you'll get a runtime error if you're unable to convert whatever's in the text box to a number value. So when we don't enter anything into that second text box, when that stays empty, that emptiness is itself, it's not something that can be converted into a double. They consider it to be more of like a string or char data type. Well, I would even say it's a string or a char. It's more like a null data type, or a null version maybe of like an empty string. Like instead of having a string that contains stuff in it, it has a string that contains nothing in it. It's just a blank string that has only quotation marks but nothing actually in it. So the way we fix this would actually be with something called a try-catch statement. Because anytime we have something in a text box that we're trying to convert into another value like a double, there's always the chance or the possibility that there's something in the text box, something entered in the text box, that is not able to be converted into a double, or a decimal, or an integer, or float, or whatever. So if I typed in a bunch of letters, these letters would also give me the same type of error message, where we are unable to convert whatever is in this text box into a numeric value. So to fix that, you can do a temporary fix if you want by just quickly commenting this out so that it doesn't do anything. So when I run the code again, 125, add, and there's no problem with that. But that's not really that's not always the best solution. Because if you do it that way, then you have to go back in and re-comment it out every time you want to use this POW thing. So a better way to do this is using something called a try-catch statement. So let's put this all together to make it more compact. And what a try-catch statement does is it looks for any kind of runtime error like the one we saw earlier where the program crashed on us. And if that specific runtime error, if it happened inside the try statement, then what happens is that everything in the try statement gets completely skipped. And furthermore, the good part is that because we have it inside try-catch statement, that means that whatever the runtime error, whatever causes the program to crash, it will no longer cause the program to crash because it's inside a try. So let's say, for example, in our previous example, this line of code failed and resulted in the entire application crashing because we tried to convert a non-number variable into a number variable. Because you can't convert like a blank space into a number. You can't convert like a sentence into a number. You just can't do it, right? So what's going to happen here is when or if any of these statements might fail or cause the program to crash, then what will happen is, like I said, I think I mentioned this already, when that happens, the entire try statement gets skipped totally, and we skip directly to anything that's inside the catch statement. So the catch statement is usually going to contain some kind of output that is designed to tell the user that they input something invalid and to tell them how to input the correct value or how to do something correctly. So I'm going to do something called a message box, which does exactly what it sounds like, is it outputs a message box pop-up, and you can give a message to the user. So I can say, please enter only numeric variables into the text boxes. And let's go ahead and try our application, see if it works. We're still doing the cubic root thing here, so we'll do 125. We'll just let's put some random garbage into here just to be safe. We got 5. All right, awesome. Now let's go back to keeping this blank. This is what earlier caused our program to crash. Let's try it again. Let's try with a different number though. Let's try with number 8. Click the button, and we get an error message. Please enter only numeric variables into the text boxes. Because, guess what? The try statement was completely skipped, and we went directly to the catch statement because something up here caused an error or glitch. So let's do a couple more examples. Let's enter some text in here, and let's do an actual number in there. Click add, and again we get the same error message. And then let's go ahead and put garbage into both text boxes. Again, we get the same error message. What if we left the text boxes blank? Again, same error message. Now let me show you one more thing about this. It's kind of hard to notice or hard to see because earlier when we did our original calculation, we already had a 5 in this label output. So what happens now if we put in some garbage data into our text boxes? We click add, we get the error message, but what's important is that nothing gets output into this label. What's very important, is that when you have some kind of try-catch statement that catches an error, you want to make sure that you prevent the output from being displayed like so. So the output statement, where it updates the text property of the label, you want to make sure that that is also in the try statement. That's also extremely important to understand that you have to do it that way. Otherwise, it could confuse the person using your Windows form or your application. So anyhow, that's that's basically just a really standard example of using math to do stuff, using the try statement to perform some basic data validation. And on that note, we are all done. So my later videos are going to build very heavily on this, so make sure especially that you understand how to use a try-catch statement. It's very important. Oh, and also one more thing. There's also something called a finally statement. Anything inside a finally statement, it's basically anything in here is code that's going to be executed no matter what happens. So whether or not the try-catch statement catches an error or a glitch, no matter what happens, the finally statement will always happen no matter what. I've never actually had a reason to use this before, but you may find a reason to use it. I don't know. So anyway, that's it. I hope that this video has been useful, and I will see you in the next video.